Hi everyone, and welcome to Module 10, Lesson 2. This lesson is actually going to be a very quick one. Again, it was either make Lesson 1 super long or do a short one, so I chose to do a short one. Today we're going to talk about Chateliers Principle and then Solubility Equilibrium. So Chateliers Principle states that when a system at equilibrium is disturbed, the system will respond trying to reestablish the equilibrium. Disturbances include changes in concentration, temperature, volume, or pressure. So basically, you have something at equilibrium, a whole, like an equation, whatever, and then something happens to it. You add something in, you take it out, you change the container size, and that's going to affect what happens. And in order to get back to that equilibrium, you're either going to shift to the right or shift to the left. If you shift to the right, you're going to produce products and use up reactants. If you shift to the left, you're going to produce reactants and use up products. So basically, you're just trying to undo the thing that was done so you can get back to where you were. So the example, assume that they're all aqueous ions. So we've got this here. What happens if I increase the concentration of the SCN minus 1? So I'm increasing the concentration of this, which is a reactant. So if I increase that, I want to use it up. So that's going to be a shift to the right. What's going to happen is I want to use the reactants. So I will make more product. Simple enough. What happens if you decrease the FSCN? Well, if you're decreasing something, you want to make more of it. So in that case, I'm going to shift to the right. You want to make up what you lost. Pretty simple. So now here we've got a new equation here. This one's different because it has energy here. This is an exothermic reaction because heat energy is going to be a product. So what happens if I increase the temperature? If you increase the temperature, it's like increasing the products. So if I increase the products, I need to shift to the left to use up the products. Okay. What if you increase the pressure? That will affect the side with the most moles of gas. Okay. So if I increase the pressure, I'm going to have 2 moles of gas versus 1 mole of gas. Increase the pressure. Pressure is collision. So the reactants are going to collide more, and it's going to shift the reaction to the right to make more products. What if you increase the volume? Increasing the volume, let's think about it as pressure, will decrease the pressure. Okay, remember Boyle's law. So that means it's going to be a shift to the left, the opposite of the one above it. So that's the Chateliers Principle. Very simple. A lot of very easy questions can be answered with the Chateliers Principle, so you can look out for those. There will definitely be some. Make sure you look at that homework assignment. It's a good one, I think. It's got a lot of examples in it. And so then the last thing we're going to talk about is going to be solubility equilibrium. So when we talked about our solubility rules, we said that things were soluble or insoluble or slightly soluble. Well, I lied to you basically and said, well, if it's insoluble, none of it will dissolve. That's not true. A very, very small amount of it will dissolve, like super small amount. So far that we deem it insoluble. So sorry. So if a precipitate is present, the solution is saturated and a dynamic equilibrium occurs. Solute dissolves at the same rate as the solute precipitates. So KSP is the solubility equilibrium constant, which shows how much substance will dissolve in water, which is found experimentally. So here is the equation for silver chloride in equilibrium with its aqueous ions. Now, for its KSP, we can see here, it's still going to be concentration of products raised to their coefficients divided by concentration of reactants raised to their coefficients. The reactant is a solid, so there's no denominator. And for all of the KSPs, there will not be a denominator. So it's just going to be Remember, because it's solids and liquids, we do not include. So you just multiply them together. Again, raised to their coefficients, because not everything's in a 1-to-1 ratio. And my number is 1.8 times 10 to the negative 10th. It is so small, which means that it favors, not a pen, the reactants, right? Only a super small amount will dissolve. Okay. So let's see here. Let's do a couple of them, and then you're going to have plenty of time to do your practice, because this is all that we're doing for notes for today. Determine the KSP of lead chloride. There should be a 2 in here. Right there. Lead 2 chloride, when the lead ion concentration is found to be 1.62 times 10 to the negative second molar. Okay, so excuse me, what I would always do first is write out the equation. Lead 2 chloride, which is a solid, is in equilibrium with the lead ion and 2 chloride ions. Okay, so that means my KSP is equal to the lead ion times the chloride ion squared. Now it says that the lead ion concentration is 1.62 times 10 to the negative second. Okay, so what is the chloride ion concentration? Well, look at your ratio. For every one of those, I get 2 of those. So it's going to be 2 times 1.62 times 10 to the negative second. And again, I did that based on my balanced equation. So I'm going to write, which is 3.24 times 10 to the negative second. So let's go ahead and plug in our numbers. So our PB plus 2, 1.62 times 10 to the negative second. Then we're going to do 3.24 times 10 to the negative second. And I still have to square it, because this is why we always want to write this out first, so we don't forget. A lot of times you will forget, I guarantee you. That's 1.70 times 10 to the negative fifth. Again, a very small number, not very much of it dissolves. One more question, it's asked a little differently. Determine the solubility of calcium carbonate given the KSP is 3.8 times 10 to the negative 9th. Okay, calcium aqueous plus carbonate aqueous. Okay, I'm going to write out my KSP. Now, what I'm trying to do is determine the solubility, so I'm trying to find this and this. And those numbers will be the same, because for every one of those, I get one of those and one of those. So plug in everything that I know. 3.8 times 10 to the negative 9th is equal to x times x, which is x squared. Take the square root, and x will be 6.2 times 10 to the negative 5th molar. All right, that is it for this. So please make sure you work on the assignment for the solubility equilibrium, and then the one on the Chateliers Principle and the homework assignment. Take lots of time to work on that. So please take this time. It's very important that we're able to do these things, and this just comes with practice. Of course, if you have any questions, please make sure you ask me. Put it in the chat, ask at the end of class, and I'll see you next time.